Well, hey, let's take a look at the Pythagorean theorem. Now, I went and searched fun facts about Pythagorean himself, the guy who did this. He was a Greek back in the day, and you know what? Couldn't find anything fun. He really wasn't that much of a fun guy, but he sure did a lot of thinking. That's what I came up with. We got a guy who did a lot of thinking. So while he's thinking, or while he's thinking about that, let's think about this. We're going to solve problems using the Pythagorean theorem. And first of all, we just need to be aware of we need to identify right triangles. So the Pythagorean theorem only works on right triangles, not just any triangle that's out there. So when we get to that right angle, that's a nice little sweet spot for the Pythagorean theorem. There are special names for the sides of a right triangle, like the one in the solve it. So the sides opposite of the right angles is the hypotenuse. So right opposite that one is the hypotenuse. It's the longest leg of the right triangle. Each of the other sides is called legs. So all these right triangles have two legs and a hypotenuse. It seems like there's a joke there that should happen, you know. What has two legs and a hypotenuse? I don't know, that sure doesn't sound very funny. I'm going to keep going because it's Pythagorean. He wasn't very fun. So maybe fun will just happen later in this lesson. The Pythagorean theorem, named after this Greek mathematician, he looked at the relationship between these legs. And he come up with this formula out there, that a squared plus b squared equals c squared. It might be one that you're familiar with, that you've seen, because we've seen this for some time now, and now we're going to apply it. In problem one here, we've got a square tile. But what's nice about square tiles is we end up with right angles in the corners. And if you have a right angle, you indeed can utilize the Pythagorean theorem. So for this one, we know this would be side A and side B, which we can use interchangeably. And we're looking for side C, which is the diagonal of that tile. So I can go 6 squared plus 6 squared equals the C squared, which I'm trying to solve. 36 plus 36 equals C squared. I got 72 equals c squared, and I don't want to know what c squared is, I want to know what c is. So to undo a square, I'm going to square root both sides. And as long as I do to both, I'm good. And c equals, well, it doesn't equal, it's an about, because 72 is not a nice, clean, rational number, so it's about 8.5. All right, I want you to give it a try for my got it. So why don't you press pause, and you solve for the diagonal. All right, when I run my Pythagorean theorem, ultimately solving C, the hypotenuse of this, I end up finding that after squaring everything, square root it, I end up with 15 centimeters as my diagonal. You can also use the Pythagorean theorem to solve when it gives you a different order of things. Like for instance, this is your A, this is your B, and C, your hypotenuse, the one that's opposite relationship. You can still solve this. So let's put this together. So 5 squared plus b squared is what I'm looking for. And I have 13 squared. These are just getting to be some pretty big squares here. 13 squared is 169. A good one to have memorized. And I'm going to subtract 25 from both sides. So I end up with b squared equals 144. And to unsquare a number, I am going to square root it. And I end up with b equals the square root of 44, which is 12. Oh, that's a nice clean 12. That's nice. So 12 centimeters ends up being my number. Why don't you try it on the got it? So you're going to work out this one. Why don't you press pause and see what you can do? All right, when I worked this out, I was looking for the A term, and here we go. Square root of 81 ends up being 9 units. I hope you got that. If you didn't, take a look at the notes, so we did it differently. All right, so we're going to utilize conditional concepts here. Let's take a look. So an if-then statement, such as if an animal is a horse, then it has 4 legs, that's called conditional. Well, conditionals, they have 2 parts to them. There's a hypothesis, the part that follows the if, and then you've got the conclusion, which is the then. So if this, my hypothesis, then that, my conclusion. Well, the converse would be if the conditional statement switches. The conditional, the conclusion and the hypothesis are flipped. And sometimes when you flip them, that statement is true. Like for instance, if it has 4 legs, then the animal is a horse. That is not true. So that converse would not be a true statement. So when you look at the Pythagorean theorem, we can utilize that concept to say, well, if a triangle has the side lengths of a, b, and c, and a squared plus b squared equals c squared, then the triangle is a right triangle with the hypotenuse of the length c. Well, you can use the Pythagorean theorem and its converse to determine whether a triangle is a right triangle or not. So it's not necessarily about memorizing about converses or conclusions or conditional statements, but what this does is this allows us to come back to three lengths of a triangle and utilize what we know to see, is this true? Can these three lengths make a right triangle? Like for instance, the first one, and remember my A term, my A and my B legs of the triangle are going to be the two smaller ones, my hypotenuse being the bigger one. So let me go through these quickly. So I can see for A it's going to be 6 squared plus 24 squared equals 25 squared. And I'm just getting it from here. And I can see 6 squared is 36. 24 squared is, I used a calculator for that one because that's a beast. 625. And I add 36 and 576 together and I get 612. And 625, and I see that those are not equal. So that would not be a right triangle. I can also do that for B. 4 squared plus 8 squared equals 10 squared. And again, I'm checking to see to make sure I'm using the two smaller sides and my hypotenuse being the longest, because sometimes the order is not written that way. It means 16 plus 64 equals 100. 16 plus 64 is 80 equals 100, and it does not. So that is not a right triangle. Let me try it on this one. It's got to be a right triangle in here somewhere. 10 squared plus 24 squared equals 26. Wouldn't it be funny if like none of these worked? I don't know if that'd be funny. It'd be like, I think I would have some bad math somewhere, which can happen. 100 plus 576 is 676 something. Yeah, 676. And then, oh, there it is. 676. These are equal. Woohoo! Yeah. That's a smiley face with a funky looking smile. I don't know what that's going on there. So 8 squared plus 15 squared equals 16 squared. Let's see if we got two of these that work. 64 plus 225 equals 256. Add those together and I get like 289 and 256. These are not equal, so is not a right triangle, is not a right triangle, is not a right triangle. But this guy is. All right, why don't you try it out? Utilizing that proof that we used, will you determine if a 20, 47, and 52 make a right triangle? All right, what I did in red represents A, and what I did in blue and green over here represents the reasoning. And I found that in the reasoning part that it does make a right triangle. And for A, though, it does not. 2609 does not equal 2704. It does not happen. It does not happen. All right, you know what I'm going to do? I'm going to go and snuggle with a porcupine just to remind myself that sometimes love hurts.